everyone, I hope you're having a beautiful, wonderful day. This is our second video in our trigonometry section, and today we'll be covering the unit circle, trig applications, and angle rotations. Okay, let's start with drawing angles of rotation. You can draw an angle in standard position by setting up a ray on the x-axis of the first quadrant. This ray is called the initial side. The ray with the angle applied to it is the terminal side. What is the direction of rotation? Conventionally, you move the initial side counterclockwise unless stated otherwise. Having a negative angle means that you moved into a quadrant where the y-axis is negative. For example, if you move 30 degrees clockwise, then your angle is negative. A good rule of thumb is that the outermost coordinate is pointing downwards, then your direction and the angle are negative. Conversely, if you move 300 degrees counterclockwise, the direction and the angle would also be negative because it moves into that territory. Coterminal angles are angles who share the same initial side and terminal side. To find coterminal angles, all you have to do is add or subtract 360 degrees or 2 pi radians. Now, normally I tell you to pause the video and work this problem out on your own, but we both know you're not going to do that, so in this problem, we're trying to find the coterminal angle of 120 degrees. So how we solve for this, we know that each quadrant is 90 degrees, so we keep adding 90 until we reach the value of the terminal angle. In this case, it is 90 plus 60, and that equals 240. Because we moved clockwise from the standard position, the angle is negative. On the other coterminal side, we go 360 degrees plus 90 degrees plus 30 degrees counterclockwise to find the same value. And in this case, 360 plus 90 plus 30 is 480 degrees. Here's a quick preview of the unit circle, and now we're going to jump into here. Okay, inscribed in any circle, you can find a right triangle. In this case, H will be the radius, O is the y-coordinate, and A is the x-axis. The cosine of the angle is the length of the adjacent side, which is x divided by the hypotenuse, so cosine is x. This will be true no matter what or where on the unit circle you define that point. Sine is opposite over hypotenuse. Knowing that the length of the hypotenuse, or the radius, on the unit circle is always 1, sine measures the opposite leg, which corresponds with the y-axis. Therefore, your xy coordinates can be substituted by cosine x and sine x. The Pythagorean theorem and identity tells us that no matter what the value of theta is, sine theta squared plus cosine theta squared is equal to 1. Think of your terminal side as the radius. We can prove this identity using the Pythagorean theorem in the unit circle with x squared plus y squared equals 1. In that case, you'll just substitute the x and the y coordinates for cosine and sine, and then you'll work out the problem as is. Okay, so now we're going to go into reciprocal identities, which are basically just the reciprocals of the three basic trig functions, sine, cosine, and tangent. If you multiply one of the three main basic functions to the respective reciprocal identity, then they would equal 1. In this example, cosine's reciprocal is called secant. So 1 over cosine is the same thing as saying 1 over adjacent over hypotenuse, and when you multiply that, you'll have 8 over h times 1 over a over h. To simplify 1 over a over h, you take them apart, so it's 1 divided by a over h, which is the exact same thing of taking the reciprocal of it. Keep, flip, change, so you have 1 times h over a, which is just h over a. Now you multiply a over h times hypotenuse over adjacent, and you get ah times, or divided by ah, which is just 1. Okay, so we're going to quickly go over reference angles. The question is, how do I find a reference angle? So if necessary, you're going to unwind the angle, keep subtracting 360 from it until it lies between 0 and 360, and for negative angles, add 360 instead. Okay, so here we have a 135 degree angle, and we're trying to find x. We know that quadrant 1 to quadrant 2 is 180 degrees, so to find the remainder, you're going to subtract the total amount of degrees, 180, to your given angle, which is 135. So that means the reference angle is 45 degrees. Now, we know that tan is opposite over adjacent and cosine is adjacent over hypotenuse. Now we're going over quotient identities, where we take that understanding and apply it to a different set of rules. So, one of the quotient identities is tan of theta equals sine of theta over cosine of theta. You might be wondering, why does this work? Well, here it is. Tangent is opposite over adjacent equals sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse. Opposite over hypotenuse divided by adjacent over hypotenuse is the exact same thing of saying opposite over hypotenuse times hypotenuse over adjacent. Now you're going to simplify that, so it's opposite times hypotenuse over hypotenuse times adjacent. You can cancel out the h's and you're left with O over A, which can be simplified or as known as tangent. Alright, our second quotient identity is cotangent equals cosine theta over sine theta. Now this is basically the same math as before, except cotangent is the reciprocal of tangent and cosine and sine are switched. So you're going to substitute and work out the same math. Adjacent over hypotenuse divided by opposite over hypotenuse simplifies to adjacent over opposite, which 1 over opposite over adjacent simplifies to adjacent over opposite if you take the reciprocal. And that is a correct statement. So adjacent over opposite equals cotangent theta. And that is how we solved our answer. Thank you for watching. Please give us any feedback in the comment section and in our Google Forms in the description.